-3 as my 0, that will allow me to use that for synthetic. So you put the -3 out here, and then you start pulling coefficients. 1, 1, 2, and 24. Now, the reason why we like synthetic is because it's easy, but when you first looked at that, that polynomial, it was a third-degree polynomial which had 4 terms, which in the back of your mind you would say, oh, I should try and group that. And then you're like, oh, I can't group that. So, and that's okay. That's where synthetic is going to come into play real quick. So they give you a 0 to start with and to start your fishing expedition. Always, always, always drop that first term. And then you just go through, multiply, add, multiply, add, multiply, add. And in fact, if you do these correctly, you get a 0 at the end, which you should because it told you it was a 0. Now, the other thing of this is that I want you guys to get in the habit of doing is that anytime you calculate synthetically and you get a 0, please, 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 please remember, circle that. That way it kind of tells you, oh, look, that's a 0. All right? Because if the -3 is a 0, what's the term that generates -3? X plus 3. So we know that this becomes x plus 3. And in essence, what you've just done is you've factored out of this third-degree polynomial one term of x plus 3. Which meant that if I take an x out of here, what's this power has to be continued? X squared, okay? So this becomes x squared minus 2x plus 8. Will this work if this was an x to the 5th? Yes. And then this would have become x to the 4th, and then I would continue on my merry way. Now, at this point, I know that some of you guys thought that it was 4 and 2.
That was wrong.
That was wrong, correct. Because here you're looking at what times what is positive 8 that adds together to get a -2. That doesn't work because you've got, in order to get a positive at the end, the signs both have to be the same. They either both have to be positive or they both have to be negative, which means that you can't factor this one. So you have to use quadratic formula. Or if you want, use complete the square, but quadratic formula is quicker. So we use the quadratic formula. You have the opposite of b plus or minus square root b squared minus 4 times a times c all over 2a. Okay? Now, underneath the radical, our discriminant, if you will, gives you -28. Okay? So this is 2 plus or minus the square root of -28 all over 2. Bless you. 28 is got a pretty easy square rootable thing, if that makes any sense. Simplifying, that's the word I was looking for. I can simplify 28 rather easily. What do you get? 2 root 7, but it being a -28, what do I take? I. So this gives you 2 plus or minus 2i root 7 all over 2. And this is the special case that everything's divisible by 2. So that gives me zeros. Remember, this one had a 0 at -3, and the other ones would have been at 1 plus or minus I root 7. You do not need to rewrite that as 2 separate values. Whenever you have plus minus stuff, just leave it. Okay? Yes, sir. Yeah. Oh, the main equation? Yeah. Okay. What do you mean? Yeah. Yeah, what's x times x gives you x squared, doesn't it? So I took out an x out of that. These become, hey guys, remember this, whenever this gets done and you get a 0 here, that means each one of these drops a degree. So if it's starting at cubed, this becomes squared, linear, like 1 power, and this is your constant. All right, each time you go down, it drops a degree. Okay? Yes, sir.
You could just.
You'll forget it. Because, yes. The reason why I do that is because it'll say list all your zeros, and you're going to forget that one lonely zero that you found that you started with. That's why I always rewrite. Whenever I get a zero, I always rewrite my terms, and then I bring up the next piece. Okay,
But it's always going to be the
if it's given to
value
you.
that it gives you.
Correct. Because they're gonna, as of right now, you don't know how to do it otherwise.
Yeah.
And we don't know how to do it otherwise yet. Keep saying yet. Okay. We know God. It's not that tough. All right. What else want to look at? Yes, sir. 47. 47. Or 47. All right. So you have -2 is your 0. 9, 10, -17, -2. Okay. All right. First thing you do is always drop that first term. In this case, the first term is a 9 now. Multiply, add, multiply, add, multiply, add. Okay. Now, that means -2 is a 0. So I know that this is a 0. So the term that generated that was x plus 2. This becomes now 9x squared minus 8x minus 1. Before you go into anything else, just check. 9 times -1 is -9. So what times what is -9 that I add together to get -8? -9 and 1. So this becomes factorable. So you have 9x squared minus 9x plus 1x minus 1. And we do some grouping. And then this x plus 2 is here as well. So your terms are the x plus 2. It wasn't plus 2, wasn't it? Yeah. X minus 1 and 9x plus 1. Okay. The zeros that this generate then are -2, 1, and -1, 9. Okay. What do the tails do for this one? Yeah, you're right. Down, up. Tails are going down, up on this one. Tails go down, up. I know I have zeros at -2, 1, and -1/9, about there-ish. What was the y-intercept on this one? Do you remember?
2.
What's 2 times -1? What's -2 times +1? 2. -2, isn't it? When you have your terms written out, if you multiply the constant, it'll give you your y-intercept. Tails, down, up, so it's got to go just like that. Okay.
I can remember it but even with the if it's squared, if it's like positive squares, it's like the even up, down, up. And then is it just like if any of them odd is just a positive slope or a negative?
That's exactly what it is. That's exactly what it is. That's how if you break it down that simply, that's all it is. So guys,
I was so confused.
one of the things Michael was just saying is that he's just had an epiphany. He just realized he opened the door, the light went on, the whole spiel. He realized that if it's up like a cup, that meant your first term was positive and your exponent was squared, right?
Yeah.
If it was down like a frown, it was negative, it was square, right? Isn't squared even? Yeah. Isn't squared, isn't that also, positive and even?
Yeah.
So if it was up like a cup or down like a cup, if you think of it that way, it's always going to work. Positive slopes increase from left to right. Isn't that y equals mx plus b? If your slope is positive, that means your x term had an exponent of 1. Positive slope, negative slope. It's the same thing. It works the same way. If you think of it in terms of slopes and
Evens, it's up or down, and odds, it's just positive.
yeah. It's just another way of looking at it. Absolutely. Yes, sir. Sure. I used to ask. Oh wait, I'm sorry. You were first. Remember, dance moves. Dance moves. If it's positive and odd, down, up. If it's positive, even, first term. If it's positive and even exponent, it's up, up. If it's negative and odd, it's up, down. And then it's down, down if it's negative and even. Alright? We'll do another one.
So if it's negative x squared, it's down. And then if it's x cubed, because it's odd, think of it as a positive slope up to the right.
Think of this one. What's my first term? Is that positive or negative? Is it cubed? Is it cubed, odd or even? So it's all it is. Okay. What's that? Yeah. What's your disco? Joke. It's a joke. You feel shame. What? 50. Can I do this one first? Jeez, relax. Wait your turn. Seriously. Jerk. 7, 8. Okay. So go through this one. First thing I gotta do is drop the 15. All right. How much is 4 sets of 15 minutes? 60, right? If I double it, what do I get?
20. Oh, that's a really
Mapping?
Oh my god,
Okay. Better be a 0 because it told you it was a 0. All right. So you know this is a 0. Okay. That gives you x minus 8. Good. Now this is 15x squared plus 1x minus 2. What times what is negative 30 that I add together to get positive 1?
Negative 5, positive 6.
Negative 5, positive 6. Very good. So this is 15x squared minus 5x plus 6x minus 2. Oops, sorry, 3x. So this keeps coming down. It's going to give me my terms. X plus 8, 3x minus 1, and 5x plus 2. Which means you now know where your zeros are. Our zeros are at negative 8. Wait, I'm sorry, I didn't see that there. I wrote it wrong. My bad, jeez.
Yeah, exactly. I don't guess I can change this on my time.
Okay.
Yeah.
Now I have 1/3 and negative 2/5. If I go to plot this, we know that it's going to cross the y-axis at a positive 16, and we know it's going to cross the x-axis at 8, 1/3, and negative 2/5. Remember, when you're doing stuff like this, it doesn't have to be pretty. Here's negative 2/5. Here's a 1/3. Here's 8. Here's 16. What are your tails doing? Down, up. Okay? So, just go whee!
That's ugly. Okay, that one, like, I don't like that. Of course, my boy doesn't like how this is.
Looks like an awesome someone's field.
How do you find the
It's your constant.
Someone's deal.
Is that all you needed?
Yes.
Original, Hold up, guys, hold up.
Could you use synthetic something or other in reverse by a zero?
Would it find a zero?
Yeah.
Yes.
Because a equals zero you can.
Yes. 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 We talked about how we do that on Friday.
Oh.
Michael, which number was it again, sir? I'm sorry, what? We do that one first and I'll come back to you guys. Or did you have one of this? We'll talk about that in a little bit. Yes, sir. We'll talk about that later. Are you dying?
Yeah.
You okay?
Oh, wait, no, that's.
All right, so I was afraid to hear this beep beep. I'm like, no. We have to run up and go up and go. Who's the lifeguard? Anybody? Annie, are you okay? Did he still do that? No, because Annie was the dummy. We just had to go, Annie, are you okay? 50? 50? You said 50.
Yeah, you take water. You just go to the little water droplet, you click it, and then waterproof, and then you get out of it, you spin the dial, and then it'll come out and move like that, and then it'll be fine. I never got so yeah, I just got there, so I don't have one,
Why is this not working today? Okay, here we go. Anyway, so right off the bat, we've got a zero. It tells you you have a zero at -5. Pull your coefficients out. 4, 9, 52, and a 15. Start going through the process of the synthetic. Drop the first term. Multiply, add, multiply, add, multiply, add. You should get 0 because it told you it was a 0. Okay? So now we know that -5 is the 0, which means that x plus 5 was the term that generated it, and it left me 4x squared minus 11x plus 3. So what times what is positive 12 that I add for -11? Wait to say bless you, JC. There, she's thinking about it. No.
Nothing.
Gotta use quadratic formula. Okay. So yeah, it won't work because you got to get a positive at the end. So it's got both have to be the same sign. So this doesn't work. So 11, 121 minus 4 times 4 times 3, all over 8. 4 times 3 is 12. Double it twice, you get 48. 121 minus the 48, I believe, is 73. So there's my zeros. Now, in this case here, I'm not going to be graphing and plotting that crummy root. Okay? I will not ask you to plot graph roots that aren't like, 1/3, what I just did there, like the problem before that, where you get zeros that are easily workable. You can't plot that 0. You can't plot imaginary zeros. Okay? The only things that I'm ever have you guys graph and plot with ends RB zeros that are RB will be zeros that are real or fractional. Okay? Does that make sense? Okay. All right. What else you got on those? Yep. Oh, and remember, guys, you do not need to rewrite this thing out twice. Just leave it like that. Anytime you get a quadratic that's with the plus minus stuff, you can leave it as that, and that's fine. I'm okay with that. Okay. All right. The other thing that I wanted to reiterate was when you go back to when we were doing this stuff, what was it, Friday into Monday. And I was asking you guys, well, as far as what let me do this first, for what the quiz is up, what the quiz is going to look like. With the quiz tomorrow, we've only really done 3 sections, okay? We started this stuff in 6.4, which was just all factoring. Factoring and then finding zeros. All right? And that was whether it was, difference of cubes, sum of cubes, fifth degree polynomial, whatever it wound up being, but it was factorable stuff, okay? After that, after that we jumped backwards into 6.2, which was your end behavior. We did all the end behavior stuff. And after we did the end behavior, we added that to the factoring, finding zeros, because then we did the rough sketches, okay? It all kind of built together, all right? Then yesterday, we went forward again into 6.5, and we talked about synthetic given a value that was a 0, okay? I am not going to worry about long division yet, okay? I'm not worried about the long division as of right yet, because I think I mentioned this before. I planned this meanderance through polynomials differently than I have in the past years. And so I knew that there'd be a hiccup sooner or later along the way of what I thought would flow better. And the hiccup in line was the long division stuff. It doesn't necessarily fit with what we're doing right now. Okay? When we need it, we'll come back to it. But for right now, we're okay without it. Does that seem fair? All right. So what happens here is that if we go back into this, this is the style problem that I would ask you guys to be able to factor and plot your zeros and draw your tails regards the end behavior. This is nothing more difficult than anything we've done. You now know, in this case, it's asking you to factor it. They're not giving you the specific 0. Okay? So in this case, what would you do first? Take out the x. Good. So if you factor out the x, you have an x, x to the 4th minus 5x squared plus 4. And remember, it's all going to equal 0 at the end. So this was that special case then, that if you had the degrees were going down by an even amount between the first two, and the last term of the trinomial didn't have a degree because it was a constant, you would treat it the exact same way as you did any old regular x squared bx plus c. Okay? So what times what's positive 4? You add together to get negative 5. Negative 4, negative 1. Good. So now you have x squared minus 4, excuse me, and x squared minus 1. Now the reason why it's x squared on both of those is because if you FOIL all that out, x squared times x squared has to get me to x to the 4th. Okay? Now, since this one I'm saying solve for my zeros, plot with end behavior, do I need to factor this any further, or could I stop here? I could stop here because I have differences of squares, so I know that I could set all 3 of those terms equal to 0 and get my values. But if you want to take the next step, that's fine too. So you still have x minus 2, x plus 2, x minus 1, x plus 1, because these guys are both differences of squares. Or if you realize that, I just add 4 but they take the root. Add 1, take the root. But you have to not to forget plus minus, because somebody will. So this 5th degree polynomial should have 5 zeros, 0, 2, negative 2, 1, negative 1. That's good, it has all 5. When I go to plot that, we didn't have a constant here, did we? Nope, so it's got to be at 0. Then we have 1, 2, negative, 1, 2, positive. 5th degree, first term was positive, wasn't it? Down, up. Okay? So we know it's got to go through. That's all it's got to look like. We don't know how high up or how low those, what are called relative maximums, relative minimums go. We're not going to worry about that. Okay? And also notice, what did I not use at all for any of this?
Number.
Ding, 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 ding.
So we have a no calculator.
Yep. Pretty much most of this is non-calculator polynomials. Okay.
Calculator technique.
Not really. You guys get lost in the calculator. You get lost in the calculator. All right. So something along the lines like that. Okay. Also, there was one in here that we dealt with multiplicity. I forget which one you had that. Do you guys remember which one of these had the multiplicity? Top of your head? Yes, the bottom right now, number 6. Yeah, number 6 had that. So again, just as a reminder, when you have factoring and you got multiplicity and you had to plot zeros, as you go through to do something like that, you still factor everything like you would normally. You still find all of your symbols just like you would normally. You have x squared minus 4x plus 4. This gives you x minus 2, and x minus 2. That meant that your zeros are located at 0 and 2 with multiplicity of 2. Okay? What happens when you have multiplicity that's even? It bounces and changes direction after 0. It bounces there. Okay? Now, tails tell you it's doing what?
It's going up. Wait, no.
It's down up. It's telling you it's got to be down up because it's positive and odd exponent. I have a 0 at 0 and 2. So I know it's got to go up through the 0, change somewhere, bounce and go. That's all I know what it looks like. Whenever it has multiplicity, it bounces, whether it's bouncing upward or sometimes it bounces below. I think we had one like that with a 4th degree. I think we had a 4th degree that bounced at 0.
Can you have any multiplicity?
Yeah.
4 times?
Yep. A 4-time multiplicity just bounces at whatever value it is. Yeah. Multiplicity can occur anywhere. Okay. And we'll have that a lot soon. Yes, sir.
With the higher multiplicity, wouldn't it be more complex?
What do you mean?
Like, harder to balance.
I guess it depends on the function. It depends. I'm not sure how to answer that, but I would imagine it has to depend on the function, what it would look like, because it could be anything really. But yeah. Yeah. No, if it's an odd multiplicity, it just goes through it.
Okay.
Yeah. Remember, guys, if it's an odd multiplicity, it just goes right through it. It can be a multiplicity, an odd multiplicity of 5. It just goes through it.
Yeah, like,
So if you think about, we did this. Okay, what's your 0? It's 0. 0 with multiplicity of 3, isn't it? If you look at the graph of that, it just does that. It just goes right through it. That's all it does. Higher, it doesn't matter as long as if it's odd, it just goes through. No matter what.
That's where 0 nobody cares about.
I asked him why. And then you were like, it does.
When you go through it, when you think about it this way. When you have an odd multiplicity, it can occur when you think about positives and negatives. It could be either or, positive and negative. If you multiply -1 times -1 times -1 positive. And that's how that bouncing occurs. So it depends upon the sign value. When it's an even multiplicity, no matter what, it's going to equal that value. Because it sits there because of the powers. Because no matter what that power is when it's raised to, if it's a negative, even amount, it's any negative value squared, 4, 5, 6, whatever. It's always going to be positive. That's why it's power. It has to do with a lot of what are called permanent functions that you'll learn more about in the recalc and counting. Here we just, it has a lot to do with the functional part of it, where you start looking at the inverse values and see how things work. We're way before all that. It's just easy to say it goes through. Algebra 2, we don't tell you all the rules. We just kind of get you up to it that you want to look at. So we got that. What was the other one I wanted to show? Oh yeah, sum of cubes, difference of cubes. Again, same idea. If you had that, back here, I think we did one out of, what number was that? Like 6-4. If you go back through the calendar, I just looked at the PDF files real quick. It's 6-2, 6-4, 6-5. I did this one earlier where it was f of x 3x to the 4th minus 24x, and I wanted to find all my zeros. Gentlemen, I wanted to find all my zeros here. Take 3x out, good. If you take 3x out, you're left with x cubed minus 8. That drops you to that difference of cubes. Remember there was a special pattern for that, and you guys found out it was pretty easy. So this becomes 3x. Here you get x minus 2. This becomes a trinomial that was, excuse me, first term squared, multiply the two together, change the sign, last term squared. Okay.
You said something.
That was that AB stuff?
Yeah.
So a cubed minus b cubed was a minus b, a squared plus ab plus b squared. And if it was a plus b, it was a plus b, a cubed minus ab plus b squared. That's right, that's a square. Okay. Now, at this point here, two of those values are easy to figure out your zeros, 0 and 2. The other one you had to use quadratic formula for. That third one is going to give you imaginary roots usually. Okay, it will give you imaginary roots. Yes, sir. What's this cube root of 8?
Oh.
Okay. So here you wind up with negative 2 plus or minus 4 minus 4 times 1 times 4 all over 2. So you get negative 2 plus or minus the square root of negative 12. So you have 0, 2. So you have negative 2 plus or minus 2i root 3 all over 2. And those 2's drop, and you get the negative 1 plus or minus I root 3. And this would be your 4 zeros of that value. Okay. Again, that's not something I'd have you graph because you don't know how, but it is something that I can have you find the zeros of. Okay? Yes, sir.
Do we have to change it?
Yes. Always simplify. Always simplify. All right. What else we got? You had one. Oh, if you look like this, well, first of all, what are your tails doing? Your tails are up, up, right? So here, I know that my tails are up, up. I'm at 0 and 2. So it's got to go through those two values, but then somewhere down here, it changes direction again. So you can have up to 3 changes of direction. So it's probably something like this, somewhere in there. But if you throw out a graphing calculator, you can kind of see it. This is nothing that we're going to wind up graphing. I might just tell you, I might ask you, what are the tails doing? I might look at this function and say, hey, what are your tails doing? You would say, up, up, and you go to the next problem. You have to write something. Yeah, you can't do plus minus. All right. What was the other thing I was going to show you guys? I think that's about it. It's really straightforward. I don't think the stuff. I know apparently you guys were asking questions about the quiz here. I don't think it's any more than like 6, 7 questions. It's real short. It's pretty straightforward. If you think about it, you've got factoring, tails, and plot zeros with tails. Okay, there's not too much going on as of quite yet. Friday, I know, Michael, you're really excited about this. We're going to go on our fishing expedition.
Whoa, wait, what are we fishing for?
I know. Don't talk to me about catfish. That catfish took my lure last week. I went looking for him yesterday.
Go noodling for a Hey, Mr. Murphy. Let's just say go to fish fishing the cat.
That's not good. That's not good. What's that?
Go noodling.
No, I'm not gonna do that. It's cold out. But no, I'm a big. I see what you did there. Yeah, I'm a big fan of fishing. We have a really nice pond by our house. We fish all the time. Yes, sir. Sure, if it brings you back. It's a song reference. No, I'm not going to go noodling. But no, the catfish that took my lure was pretty big, though.
You're gonna go looking for him again.
He's like my white whale. Call me Ishmael. Is that the right book? I don't know, it's been like a lot of time.
When you catch him, you're cooking and bringing them home.
No, I don't think I want to eat anything that's in that pond. They're fun to catch, but you just throw them right back because then somebody else can catch them.
No, makes it the most humiliating
No, we catch pretty good sized large ones there too. So. What else you got?
Stop talking, Reggie.
Forgot about math.
I'm up there.
Can you tell me how to do that thing where you run zeros?
Nope. Try to see. It's easy.
Rainbow
Yeah, they're good to use it once. The biggest fear for that's not a cube. Think about your cubes. Okay. 8, 27, 64, 25. That's, and then they start getting way too many. I start thinking about it. Let's put it out there. I don't try to get as large. I mean, even if I had like 64, I could do 128, but your GCF would take it out and see the 64. So I want people to play along with us, but it'll be within GCFs in here. So it's so some things, but since I don't let you guys play it a lot of times, I don't make it figure it out.
Okay.
Because then it's stupid. Same thing with those roots. This one isn't bad, it was 12. You know, the one we got over here, the one before it was what, 73. But when we got to it, where was it? I mean, 11 squared is 121. So you know that. 48 times 4. I'm sorry, 12 times 4 is 48. And then you do that. 121 subtract 48. All right. It should be. Like I said, I don't. None of the problems that we had were back over your head. They're all numbers that were easily heard.